Hello everyone, welcome to my YouTube channel. In this video, this is the third video. First video I gave an overview, what is our project about, and second video I showed how can we create our virtual environment, why it is necessary for our project. Now we are going to do our data analysis project from beginning to end. There's an outlier analysis, we will do exploratory data analysis, data cleaning process, and visualization. We have some questions to answer as well. This is the real data analysis process, and if you get a job in the future, this is using these footsteps. What I did here will help you in the future. Exactly what it's help you to solve your problem in the future. Okay, so I created this table of the contents because it's easy to navigate in your notebook. This just consists of you are just using this hash here and giving in this introduction, and at the end, wherever is just you add this for example, I just used here HTML anchor here. It's just the HTML anchor, and just give this ID. Then whenever I click here and here, whenever I click this introduction, it will just navigate me to that section. Okay, it's really intuitive and easy to use, and it will help you to navigate in your project, because at the end notebooks are become really long, and just navigating is really hard. So what we have introduction section. We will just describing the data set. Then we will start data wrangling process. We will assess and just look at our data and just get general information. Then we will assess our data. Then we will jump into the data cleaning process, then exploratory data analysis. Then we will do outlier analysis. Then we will make our comment. Then pass into the exercise. We have some questions here. So what is our data sets? Our data sets is snow and ice removal in 2022. It belongs to counties and municipalities in the Massachusetts. So first of all, we have snow and ice data. It contains the municipalities' municipal expenditures on snow and ice removal 2022, and road miles data, which contains total miles of road in each municipality. And we also have a 2022 estimated population estimates for each municipality in that fiscal year as well. So, okay, we have a few notes to solve. So we have some questions to solve that. First of all, we are going to merge these data sets using any programming language. We are going to use Python here. And for data analysis, we are going to conduct data analysis and answer these questions. Which county spent most on snow and ice removal in 2022? Second question is, which municipalities spent the most per road mile on the snow and ice removal in 2022? And which municipality had the largest total budget deficit for snow and ice removal 2020? Anyway, so these are the questions, and we will create some visuals as well. So, and I added some more questions as well. I just added the D. So at the end, we will see. I don't want to just, you guys can, because I'm going to share this notebook, you guys can read everything in detail at the end as well. Let me give you, so let's start to read our data set first. There is a column explanation here, and DR code is a unique identifier. We have municipality name, county name, fiscal year, original budget. The important thing is supplemental appropriation transfer into snow and ice. This is additional funding. Each municipality is allocated supplemental allocation for this snow and ice removal, and there's expenditure. Expenditure is total amount spent on the snow and ice removal. There is a state reimbursement and federal reimbursement, and the amount of reimbursement to municipality by the state or the federal government. These two variables, the purpose of these two variables, and deficit between total expenditure minus total available finding. Total available finding means total first allocation plus supplemental appropriations for this snow and ice removal. And And these are the roads. We are going to all these roads and mice, highways, T-town expected, DCR, Massport, State Park. We were going to only use T-town expected because this is where the municipalities are responsible for that. I don't know what other places who are going to remove snow and ice from the other places. But anyway, so this is a this overview, and I will explain on the way. So whenever we just starting a project, at the end, we will need more maybe libraries, but now we are going to start with this one. We have Pandas and of course Seaborn, and these are the functions I created. These are the modules. Let me show you here. And these are the modules I created, EDA because writing same thing again and again is not make sense and is not programmatically efficient. Because, for example, to describe data set, we were looking at the index, shape, data types, head and tail. Sometimes whether is there a null value or not. So to using these functions are really intuitive, and I will explain each functions, their purpose and how they are going to help us for our data analysis project. Okay, here, let me just a little bit make it closer. Okay, yeah, this is good. So this is a function I created for the save the high resolution images, because at the end, you are going to create an executive report, or you are going to report to your manager. You need high quality images. You guys can just copy paste in this function, and it is really helpful. I created this folder here. So basically, even if I didn't create it, this one is actually creating this using this path library. It's going to create as images and snow and ice removal folder. Then at the end, it will save our figures or plots or plots to in that folder. Okay, let's run this function as well. I could import that one from outside, but I did it already. Okay, I'm now, these are the Excel files, and using pandas pd .read Excel function. So we are going to read our files and we read it. These are relatively clean data sets, but there is a 2 upcoming video. I will show more messy and more dirty data, which I used in the, I saw in the Google data analysis project, but I just created everything from the beginning, not on their way. Okay, so this is, let's start with assessing population estimates data set. So here, I'm using this checkdf function. This function, as you guys can see, is taking the population estimate data set, and these are some arguments I created earlier. So let me show you how this, let me run this function first, and you will see the result. As you can see, we can see the index, and this is really important because you can see the steps, and we have 350 rows, and there is no any gap between them, and each goes one by one. And also we can see the shape of our data set. We have 351 observation and 4 variables in this data set. And also, as you can see, the type of the data sets, we have DR code. As I said, this is unique identifier. At the end, first the beginning, when you are looking this data set, you should just check it whether your data types are consist with your data observation. For example, DR code says integer. Now I am looking head and tail to my data set, whether they are integer or not. And yes, and it consists of, if they are not going to match, I will just take my note. Okay, this one is not, it's not the same as we see here. For example, it says object, but it's actually integer or number, right? So we see that municipalities object, as we can see their object string, and we see counties object, as we can see their object. And as you can see, 2022 integer, this is 2022 means our population. For example, when we're assessing our data sets, 2022 is not, explain the purpose of that variable. So I will take a note in that whenever I see this, I will say that I'm going to change this column name more explicit, which describes the purpose of this variable. I could say, for example, 2022 population, right? Okay, so as you can see, is there any duplicated value? It's false, there are none. And this is another check we would do when we are starting. And is there any missing value? We don't have it. Total missing value. Anyone has it. So total, there are no missing values as well. So this is describe function. How can we read this describe function? As you can see, we have count, unique, top frequency, mean, standard deviation, mean, 25 quantile, 25% of the data. This is median. This is 75% of the data, and this is the maximum value of our data set. So for this mean, standard deviation, and the others, we could only use these ones for the numerical values. For the count and unique or top and frequency, we could use these ones for our other categorical variables. So as we can see, the DR code is not important, so it's just a unique identifier. We can see municipalities. We have 350 municipalities. As you can see, top and frequency 1. That means each of them are unique, and which is correct. There are 351 municipalities in the Massachusetts. So counties, as we can see, we have 350 county rows, but number of 14 unique county. That means we have 14 counties in the Massachusetts. When I started, I checked it. Yes, there are 14 counties, and top one is Worcester. That means 60 municipalities in this Worcester County. This is as we can observe from the frequency. And another important variable is the population. As we can see, mean value is 19,891. But as we can see, standard deviation is really high. That means our data set is has outliers in this first observation, because as we can see, median value is 10,500. And as you can see, there are some municipalities has really big cities. So for example, probably this one is Boston. Anyway, let's continue. These are our first observation, and I'm just checking the because this one municipality is unique. Is there any duplicated? To check it and whether they are unique or not, and which is false, which is a good sign. So let me show you the how this function works, since it shows it's a really basic function. Here, this check df I created takes a data frame, and it just gives us a general side as we observe here. And what it does is just basically prints a data frame that index what we see in the first one, data frame that shape, and data frame that data types, and data frame that head, data frame that tail. And I just use this function to get a first glimpse and first sight of from our data sets. It's a really intuitive function. I'm just getting data frame and using its function, and also using print function here to separate each line from each other, as we can see here, right? Okay, let's just continue. Okay, now, okay, so let's look at the other data sets, road miles. Let's run this one. As I mentioned, this one contains the roads in the how many mile road each municipality has. As we can see, this is the same, no problem. We have 351 observation and 11 variable. And as I mentioned, in here we have municipalities again. In this exercise, each municipalities we are going to use for our calculation or analysis, we will use city town accepted. But just in case, I want to make sure, for example, we have total miles, and these whether they are going to sum up the total miles, and which is another way to make sure this data is correct, because at the end you always keep looking for whether you have correct data or not. So for example, here, there is a DR code, as I mentioned, in Mass Highway. And let me just go through. They're all numerical, as you can see, and they're float, integer, and object, which is a correct. We don't have to take any note. We only have one note, as I said, the descriptive name of the column in the other table. We said we were going to change that one. I took a note at the end. Okay, let's just, is there any duplicated value? False, there is no duplicated value. Is there any NA value? There are none. As you can see, total NA is none. As we can see, we are not going to get any result from these ones because they are numerical values. As we can see, we have, these are the mean values, standard deviation mean 20%. Okay, as you can see, 25 quintile and 50 quintile, there are some of them are 0. That means these ones are really, they are not common. They are just really rare in our data sets, and it's not going to, and you should just, for example, if you just put in the outlier analysis, you might think they're outlier. Actually, they are not outlier. They are not just common, and they're just, as you can see, there are still 0. Probably there is just one or one municipality have those ones, or some of them doesn't even have it. As we can see, let's just look at the sit down accepted. As we can see, this is our mean value. Let me just look at the standard deviation, and there is some variability in our data set. As we can see, actually, mean and median value is close, but as we can see, we have some outliers as well. Here, as I mentioned, there are some cities are really big, and that's why we have this value, because there is a really big difference, 790 miles to 800, actually 2 miles of places. It's really small, actually. Anyway, let's continue. And again, I'm checking this because I'm going to, at the end, I mentioned we are going to build our data modeling process. We will create tables in the PostgreSQL environment. Then we will use these values for primary key and foreign key at the end for the merge our table to create our entity relationship diagram. Okay, let's go into the snow and ice data set. In this data set, as we can see, same thing. We are just checking. There are 10 variables. DR code, we know this is a unique identifier, as I mentioned. County, fiscal year, and these objects, they're correct. Fiscal years, yes, it has to be integer, as we can see here, 2022 original budget. These are all flawed, as we can see, they're all flawed. And as I mentioned here, this is our original budget. In the beginning, each municipality allocated this amount budget to snow and ice removal. These are the supplemental ones. And these are how much they spend. These are the reimbursement from the state and federal government. This is the deficit they reported on their balance sheet. Okay, just let's look at their first. There is no duplicate. Oh, okay. We have right now a missing value in. It says 1. Probably we have 1 row, and that are a municipality. It doesn't have values on their rows, which is 6 different variables. Okay, that means we have 1 municipalities. Yeah, 1, 2, 3, 4, 5, 6. Yes, this one 6. Okay. Okay, let's look at the described value. As we can see, okay, we have minus. This is interesting. Deficit reported on the balance sheet. It has minus value. You can't report a minus deficit, I think, in balance sheet. And we will check that one at the end. As we can see, mean values, really high expenditure, and this is the original budget. And there are really high standard deviation. That means they didn't estimate their original budget. They need to add more. Yes, they needed to add more supplemental meanings. Okay, that means there are some municipalities, because standard deviation is really high, there are some municipalities has really huge amount of budget when we compare the others. Let's see the median value here. Yeah. So as you can see, median value $200,000, but as we can see, mean value is this amount. So that means there's some outliers and affect our analysis. So that's why our mean value is higher than the median value. Okay, is there any duplicated? Same observation, there are none. I think let me just check how long we have been doing. I think we can continue. So these are the comments, as we mentioned before. I took into notes, and as we said, is the shape of the data set. There are no missing values. And whenever I just create this comment values, just talk about the quality and your data sets. And we said, okay, this variable has a high variance. We took a note, and this indicates mixed and similar large municipalities, as we mentioned before. And actions, column 2022 is non-descriptive. As I said, we are going to change this one. So this is our action for this data set. For other data sets, I mentioned we are going to check whether total miles columns sum accurately sum up the individual road mile categories. We are going to do that one as well, as we show here. So this is our action here. We are going to check that one. And snow and ice table data types are correct and consistent. We mentioned just checking the data types and our observation. All the tables are correct. As I said, this is relatively, these are some actions I took notes. I mentioned there are some negative values in the data set for supplemental appropriation expenditure. Because how can your expenditure will be minus value? This is weird. That's why I took a note for that. And also, how can you make a minus expenditure? But if you guys know some accounting, those accounting values, probably they just allocated some amount of the budget and they had to take it back. That's why we have it. So for this one, I found that this one is the Brockton, and is the only municipality which has negative expenditure. And I checked their data source. It is also same. Then I look at their budget report. It seems it's just somehow they just trying to balance their. Probably they take that money back to their budget, so that's why there is a minus value. But you have to question those kind of things and understand what are the causes of what is the cause of this minus value, because it's not intuitive, as I mentioned before. So there are one missing value we mentioned, some columns we mentioned negative value, and I mentioned this one has small typo. We can change it. We don't have to. It's small things. And also some column names are really long. I am going to make it smaller because when you are visualizing your data in the graph and axis, you will see some names are colliding each other and just hard to see the column names on the. Okay, so and also in this expenditure, Snow and Iron expenditure file, I'm going to make sure whether the reported deficit is same as I'm going to calculate it manually, how much they just allocated, total original budget and the supplemental one, and also how much they spend it, and just make sure whether their report in the balance sheet is correct or not. This is one of the important thing in there. So, okay, whenever I just start, now we are starting the data cleaning. Now I'm copying my data sets as giving them a clean name, because it's just easier to do that. Because at each stage, I would recommend you to just keep your different data sets name, so you can just follow what you did and what are the difference between those data sets. Okay, we said we are going to change this column name. It's basically we are just writing our code. We said define which table, this table, because just intuitive, you will understand what you did in the past. For example, a few days later, a few months later, when you are periodically doing the same report, you will understand what you did and why you did. So this is intuitive. We are using the Pandas rename method, and we are giving this column, take this column and change it to this. in place through, if you don't say in place through, it's not going to change it. It will change it in that's just one run, but after that it will stay the same. That's why I said in place through. We are checking, we write our code, and we are testing. Yes, we changed the column name. You can use the rename method to change in column name. We said we want to make sure whether a total miles column accurately sum up the individual road mile categories. And we are using here, for example, I give a tolerance. This is a real small tolerance, and we can ignore it. This is a, in my choice, you can just increase or decrease it. But in this case, it's just a real small tolerance for the road mile. It is not important. So we are road mile iter rows. What iter rows method does, we are going to go each row in this data set. We have 350 observation. We are going each one of them. This one is index. This one is contains row values. What does that mean? Index 1, index 2, index 3 until the 355. Each rows means each observation in that data set. We said is mass high wave and the others. As you can see, I am adding mass high waves, T-town accepted, and DCR, Massport, state parks, each individual categories, and to some of those columns. And here, this is a Python testing method, assert. I'm saying their absolute value. Absolute is important because it's just how can we change if it's smaller than the tolerance. And if it's not, it's going to tell me that if this assert value is not correct, then it will tell you if it's not smaller than the tolerance, if it's not their difference, not smaller than tolerance, it will give me an assertion error that will say, this is a printf, it will say row, whatever index is, does not sum up the correct with the tolerance. When I run this, it will run without problem. Let me just remove this tolerance here. As you can see, I get an assertion array, row second does not sum up correctly within the tolerance because there is some issue, probably typo or miscalculation, but we can ignore this amount. Okay, so as we can see, we make sure each one is summing up correctly. This is our problem as a data analyst. We have to check everything. As I mentioned, I want to change name of these column names because they're really long. When we just created the graphs, they are going to look ugly and just it's just closed our axis view. We will not able to read our data set. I use the same rename method from the Pandas and give it the old column name, give the new column name, in place through, and it will change it. Let's just test it. Here we go. Yes, which is we done it correctly. And then we said there is one missing value. And okay, so this is calculated ratio and the number of the missing value table, and also give us the NA columns. These columns have the missing values. Let me show you that function. Missing values. This one is summary now. Probably data preparation. Where's the missing value? Yes, missing values table. It takes the data frame, and I name, and if we this is another argument. We just first assign it to false, but if we can say true, it will return us the NA columns. What it does is just checks whether this is a list comprehension. Go to is null in the column more than one, and then it will add that NA columns into it. Then there is also this calculation for the as you can see, I showed that this little Pandas data frame shows the number of missing values and ratio. This is just one, and just you can ignore. It's just a 0. We can say that. Okay, let's check what is it. As I said, this is 𝐂𝐨𝐦𝐩𝐫𝐞𝐡, and I checked their annual report in 2022, actually, and the data provided division of local service says that they don't have budget for the snow and ice removal. So in this case, now I just checked their website, and I am sure as a data analyst, I can fill this value with 0. But otherwise, if I don't know what is the reason for this missing value, you cannot do that. filling missing values with the mean value, median value is not correct way. Best way to find what are those missing values. It's come from some problem from the software or some typo or somebody didn't enter that one. So you should make sure whether this missing values come from some systematic issues or there's an error or even you don't have this data. But right now we just, for example, we used to work in the customer data in the bank, and sometimes customer didn't have an address or just some demographic information. So we had to make sure why they don't have it or some problem, and we realized that they're older customers, and at the time they didn't collect that information. Then we take an action, just create some documents. Let's collect that information for future analysis, right? So in here, I'm just, as I said, I just look into details in the reason for the why there is a missing value in this data set, find the problem, then fill that value here. As you can see, this means snow and ice cleaning log, and which means that index, get that index and fill that values with 0. And as you can see now, we are going to check it. There is no missing value. And same function, we are just, as you can see, before it was showing us that this values, now all returning values is explicit. Okay, now we handle the missing values. And as we said, there are negative values in the data set, supplemental and appropriation expenditure, and this could indicate the reimbursement or maybe budget adjustment. So, but should be confirmed accuracy. So, and I found that it's a Brockton, and I checked the data source. I mentioned BOW, and that means there's some kind of they did a budget adjustment for that. It seems the same. As you can see, it looks ridiculous here. By the way, this function is just to describe what we use in the before. We are using just one for variable, but I'm applying this one to see the better view. Without this one, for example, if I remove it here, remove it. It's really hard to read, right? This is a million or billion, right? Or 1,000 or 100,000. So this one is really help you to understand what this function. This apply method is you can just this method is apply each row, whether you assign as defined here. This one is I just use the lambda function. You can use or your user defined function as well. So this one is get that X value and then format it like this. So as we can see, we have this value, and we are going to check that one. Here, I'm just sorting these values, which one, and there is only one value, as you can see. Other ones there are some 0. That means they didn't have any, as we can see, 𝐂𝐨𝐦𝐩𝐫𝐞𝐡𝐞, they don't have any original budget and supplemental, but this one has minus values. As I can say, this is consistent, and I'm going to make that value not minus, and I would actually prefer it just as just a 0, instead of just adding them. Okay, what I'm doing here, total and ice streamer budget municipal sum of total snow and ice budget for a municipality is the sum of the original budget and supplemental appropriations, right? So what I'm going to do to find the total budget, I'm going to sum total budget with supplemental funding snow and ice. And then what is the total expenditure on snow and ice is total expenditure minus any reimbursement received. What I'm going to do, and snow and ice total expenditure, snow and ice equal snow and ice total expenditure. And I'm doing here, if it's less than this, what does lambda function does is taking a value. If that value is less than 0, which is I'm doing for Brockton, just make it 0, else just take that exact value here. Then we are just, and then for expenditure, we are just subtracting those state reimbursement and federal reimbursement as we mentioned our instructions. So now we have total budget and total expenditure. So I mentioned, I take a note here why I did the 0, as I already explained it. Now I'm going to just check it So whether is total expenditure and that their deficit is correct or not. What I'm doing here, getting the just sum of columns, total original budget and supplemental, it's no one eyes, and getting the expenditure right and expenditure to appropriation, and then I'm just making to make sure those values are what I calculated are correct or not. I just made a zero tolerance. Let me explain this. I'm just actually testing what I did here and doing same thing line by line. Maybe it's not necessary. I just added, as you guys can see, the same exactly what I did, whether our calculation above is, since we did it with the program, this one is actually not necessary, but I already added. So it will be a practice for you to how to use software testing in your data analysis project. Okay, so let's calculate the total deficit by ourselves. Since we have a variable says deficit in the balance sheet, let's make sure whether, sorry, just copy this way, whether their report in the balance sheet is correct or not. What I'm going to do is I'm going to subtract total expenditure from the total budget and make it total deficit calculated and make sure it's correct. And I'm going to match it with the they reported. For example, right now, and what I'm doing, snow and ice deficit reported on balance sheet equal to, not equal to total deficit calculated and less than this amount. Why I'm doing this one, that means, and they all actually just didn't show any their total deficit calculated. They didn't actually, they have a deficit, but they didn't report it. That's what I am doing here. And there's 4 different columns. Let me explain this again. This one is reported on the balance sheet. We have in our data set, this one, what I calculated. I'm saying that check whether this one is equal to that one, and also checked whether this one is less than 0. And I'm looking at them, there's just 4 value. And as we can see, they're just -1. And that means there is not really big difference with these values. So we can just ignore it. Probably these ones are rounding error. But this is really one of the important observation in this analysis project as well. Okay, so let's make sure how many we have. What we are looking, how many municipalities reported deficit in their balance sheet. So as we can see, 57 municipalities. How many municipalities spend exactly their budget? 99. And how many municipalities spend less than their budget? As we can see, 191 municipalities spent less than their budget. But also we are going to add 4 of them because there's a rounding error. These 4 of them is actually spent exactly their budget. So that's why this one is 103 instead of 99. And we are checking, we have 351 municipalities, which is other way. How can we check our data, whether what we did is correct or no? Now I use this total deficit calculated. I created this variable. Now I can drop it easily. There's a drop method you can use in the Pandas, and it will take that column, and you have to say, because you are dropping a variable, you need to say axis1, because I believe it's default value is axis 0, and you can say in place true. Okay, we took this node and we came to exploratory data analysis. I think this video is really already really long. Let's just continue exploratory data analysis in the second video, so I can just a little bit take time to refresh myself as well. Thank you so much for watching my YouTube video. Hopefully see you in the next video. Please feel free to ask any questions, because I already worked in this data set before. Maybe I am not explaining everything in details. Just add a comment in the video. I'm happy to answer any questions you have.